this video, we will try to understand what is electric flux. Students, as you know that if there is a charge in a plane and if we have a test charge, then if the test charge is released, then this test charge will move either towards the charge or it moves away from the charge. It depends upon the nature of the charge. If suppose this charge is positive and you have here a test charge, and as we know that the test charge is always taken positive, small positive charge are taken as test charge. So this one is also positive. So this charge when released, suppose it is released here, then this charge will move away. It will move away from this charge. It will move along this line. If suppose it is released from here, then it will move along this line. If it is released at this point, then it will move in this direction. And if it is released from this, then it will move in this direction. So it moves radially outward from this positive charge. So for a positive charge, this is the positive charge, the charge moves along the radius like this. It moves like this. These lines are known as along which the charge moves. These are nothing but these are electric field lines. These are electric field lines. It originates from the positive charge. In place of taking positive charge, if we take negative charge, suppose this is minus q, okay, and here you have a test charge, what will happen? Now it is negative and this one is positive, so test charge will move in this direction. It will come towards, suppose this is the test charge, it will move towards this charge. This is the test charge, it will move towards this negative charge, because we know that there is attractive force between opposite nature charges. Here if you have this positive charge, it will come along this line. So the line along which the charge moves is nothing but is the electric field lines. Clear? So for negative charge, the electric field lines come towards the charge, and in case of positive, it goes away from the charge. If the electric field lines are very close, what does it mean? Electric field lines are very close. As we come closer to this charge, the distance between the lines are decreasing. The distance is here distance is larger. So as we move away, the distance between the lines is increasing. It means if you take certain area here, suppose you take this much area here, so the number of lines are 1, 2, 3, 4, 5. But if you take that area here, then you find that only 2 lines are passing here. So the field is strong here, the number of lines are more, so the electric field is stronger in comparison of here. So more is the number of lines, stronger is the field, and smaller numbers shows that the field here is very big. If suppose these lines further moves away like this, and you take a same area here, now no lines is passing here, the field is very weak here. So the number of lines passing here, and here are not same, and the quantity which we want to study here is electric flux is nothing but it is the number of electric field lines passing through a surface normally is known as electric flux linked with that surface. Clear? What is electric flux? The number of electric field lines passing through a surface normally is known as electric flux. Okay, here we see that the distance between the lines is changing. Changing distance shows that the field is not uniform. The intensity of the field is, as we move away from the charge, is decreasing. But if the lines are parallel, then if the electric field lines are parallel, then the field is uniform. Suppose we have this surface, and these are the electric field lines passing through this surface. Electric field line passing through this surface. These lines are parallel, so this is uniform electric field. Here we see that the three lines are passing through this surface. And as we have defined that the number of electric field lines passing through a surface normally is known as electric flux. Now take another example here. Here we see that C1, E2. E2 is stronger than E1. Why? Because here the number of electric field lines are very close in comparison of this. So the number of electric field lines passing through this surface are much more than the number of electric field lines passing through this. As we see that the electric field, the intensity of electric field is increasing, the number of lines are also increasing. So we can say that the electric flux is denoted by phi E. It is directly proportional to the electric field. More is the electric field, more will be the electric flux. Clear? The first quantity which we have got here is the electric field. If the intensity of electric field is higher, then the electric flux will be more. Clear? Electric flux is directly proportional to the electric field. Higher is the electric field, more will be the electric flux. Now, take another example. Suppose we have different surfaces here. One surface, and this one is another surface. This is another. And here we have the electric field. Electric field from left to right. These lines are parallel. If suppose say this, then like this. Okay. Here you see that this surface this much, this one, and this. What is difference between these surfaces? They have different areas. Say this area is A1, this is A2, and this is A3. Here A3 is greater than A2 is greater than A1. Area of the surface are increasing. These three surfaces are kept in the same field. Field is E. But we see that the number of lines passing through this surface is 1. Here the number of lines are 1, 2, 3. But here the number of lines are 1, 2, 3, 4, 5, 6. And we have defined that the number of electric field lines passing through a surface normally is known as electric flux. Here we see that the number of lines are increasing by increasing the area. As the area is increasing, the number of lines passing through the surface are also increasing. So what point here we are getting is that the electric flux is directly proportional to the area of the surface. Second point. First point was electric flux was directly proportional to the electric field, and the second point is electric flux is directly proportional to the area of the surface. More is the area of the surface, more will be the electric flux. Electric flux means number of electric field lines passing through the surface. So we have got two quantities here, electric field and surface area. Electric flux is directly proportional to the area, and electric flux is directly proportional to the field. Now, is there any other quantity upon which this electric flux depends? Suppose this is the surface. This is the surface, and some rays are coming from that side. If suppose I hold this surface like this, so maximum number of lines will pass through this surface. But suppose I turn like this, so as I will turn it in this way, so number of lines passing through this surface will decrease. And when this will become like this, so number of lines will be nearly 0. It means what? It means the number of lines passing through a surface also depends upon the angle made by this surface with the electric field. As the angle changes, the number of lines passing through the surface also changing. Number of lines are also changing. If we rotate this in electric field, when lines are coming suppose from that side to this side like this, so when the surface will be like this, the lines will be passing normally, that is, it is passing in the direction of the normal to the surface. The normal is here, or you can say normal to this side also. In that case, maximum number of lines are passing. But when it is in this way, that is normal is in this direction, it is making 90 degree with the lines. Lines are coming from that side and normal is in this direction. So the angle between the normal to the surface and the field is 90 degree. We see that in this case, the electric flux is minimum, that is 0. It means the electric flux depends upon the angle between the normal to the surface and electric field lines. Now, from the diagram, we will try to understand how the electric flux depends upon the angle. Suppose we have a surface here. Say this is the surface, like this. This is the surface. The surface. It is kept in the electric field, and the electric field is here from left to right like this. This is the electric field. is the electric field. Here, the normal to the surface is in this direction. Is the normal to the surface. This normal is making 90 degree with the field. Field is in this direction and normal to the surface is here. Here the angle between the normal to the field, theta is equal to how much? Theta is 90 degree. So cos theta will be how much? Cos theta, that is equal to cos 90, it will be equal to 0. How many lines are passing through this surface? 1, 2, 3, 4, but no lines are passing through this surface. When the angle between the normal to the surface and electric field is 90 degree, no lines are passing. It means flux is 0. Here flux phi E is equal to how much? 0. Flux is 0. But take another case here. Suppose this is the surface. This is the surface. And normal to the surface is in this direction. This is the normal, n cap. And electric field lines are also in the same direction. Electric field and the normal to the surface both are in the same direction. So the angle between the normal to the surface and electric field, theta is how much? Theta is 0. Therefore cos theta, that is cos 0, it is equal to 1. Here we see that maximum number of lines are passing. So flux is maximum here. Here flux phi is equal to how much? It is maximum. And if suppose it makes some angle, in that case, say it is angle theta, then this flux depends upon this theta. When it is 90 degree, flux is 0. When angle is 0, then flux is maximum. You know that the value of cos theta is maximum and it is equal to 1. It means flux is maximum when the theta is 0, that is cos theta is maximum. When cos theta is maximum, flux is maximum. When cos theta is maximum, then flux is maximum. Cos theta की maximum value कितनी होती है? 1. When cos theta is minimum, means the cos 0, then flux is minimum. What does it mean? It means electric flux is directly proportional to the cosine of the angle between the normal to the surface and the electric field line. That is cos theta. That is this flux E is directly proportional to cos theta. So we have got three relations. We have got 3 points. That is electric flux depends upon 3 factors. Number 1, electric field. Number 2, surface area. And number 3 is cosine of the angle theta between the normal to the electric field. How this flux depends upon area, upon electric field, upon cosine of the angle? We have seen here that this flux phi A is directly proportional to the electric field. First point, phi A is directly proportional to the surface area. And number 3, this flux phi is directly proportional to the cosine of the angle theta between electric field and normal to the surface. So we have got these 3 points. Now combining these three points, we get this phi e is directly proportional to E into A into cos theta. If we remove this proportionality by putting a constant here, then this phi E is equal to a constant k into E into A cos theta. The value of this proportionality constant k is 1 here. This k is equal to 1. Therefore, phi E is equal to EA cos theta. The electric flux linked with the surface is equal to EA cos theta. EA cos theta. As we know that the electric field E is a vector quantity and this area of the surface is also a vector quantity. But the electric flux is a scalar quantity. This one is scalar. But these two, electric field and area of the surface, are vector quantities. And we are getting that this electric flux is product of two vector quantities. It means electric flux is a scalar product of electric field and surface area. So in vector form, we can write this as phi E is equal to vector E dot vector A. Clear? This is all about the electric flux. When the electric field is uniform. Here you see that the electric field lines are parallel. Parallel lines means the field is uniform. So we will have this formula for electric flux in case of uniform magnetic field. Now suppose the field is not uniform. Then how can we calculate the electric flux? The field is non-uniform. Uniform field is shown by parallel lines and non-uniform field will have variable distance between them. Suppose this is surface and the lines passing through this surface are like this. Suppose this is the surface. You can have surface of any shape, doesn't matter. The only thing which matters is how many lines are passing through this surface normally. Suppose the lines are passing like this. Here we see that the distance between the lines are not same. It is changing. It means the field is non-uniform. So calculate the electric flux for non-uniform electric field. We take a small area somewhere. Like suppose we have taken this much area. Say this area. Area is sometimes denoted by A and sometimes it is also denoted by S. If we denote this area, small area, by suppose dA. So area vector, it will be normal to this surface like this. This is vector dA. Vector dA. And if the electric field here for this small area element is suppose it is constant and it is equal to E. So the electric flux, small electric flux linked with this surface d phi will be equal to E dot dA. Clear? And if you want to find the electric flux linked with the whole surface area, then you have to integrate this one. By integrating this, phi is equal to integral. We have surface integral d phi and it will be equal to integral E dot dA. E dot dA. These two are vector quantities. You can write this as, if the angle between this is theta, so you can write this as a E dA cos theta. Clear? So in this way we find the electric flux linked with the surface when the field is not uniform. Clear? So what we have studied in this video, we have defined the electric flux first, that is, it is the number of electric field lines passing through the surface normally. And how we will calculate the number of lines? For that, we try to find that what are the factors upon which this electric flux depends. So practically here we find that it depends upon three factors. Number one, electric field. More is the electric field, more will be the electric flux. Second is the surface area. More is the surface area, more will be the electric field. It is directly proportional to the surface area. And third is the angle between the normal to the surface and electric field. The electric flux is directly proportional to the cosine of the angle between the normal to the surface and electric field. And using these three, we have got the formula for the electric flux. Clear? And that is the electric flux. Okay, bye.